We're now going to take a look at implicit differentiation. Now, before we describe implicit differentiation and what it is, let's first of all understand the difference between an explicit versus an implicit equation. Now, consider this equation down here, y equals x cubed minus 5x plus 1. Notice how we have the y isolated on one side and everything involving x's on the other side. We then say that this equation defines y explicitly as a function of x, since the y is on one side. And notice that we can plug a number in for x and we get back what y would equal. Now compare that to this equation, y times x squared minus 1 equals 0. In this case, we say this equation defines y implicitly as a function of x, since y is not isolated on one side of the equation. Notice, however, that we could take this equation and rewrite it as this by simply taking the 1 over to the other side and then dividing by x squared, so we would get y equals 1 over x squared, and then this equation does define y explicitly as a function of x. Now, the question is this. If we're given an equation like this, and we want to find dy dx, how can we do that? Well, one way would be to try to rewrite the equation to find y explicitly as a function of x like this, and then find dy dx. Now that's fine, however, sometimes it's really difficult or even impossible for a complicated equation to be able to solve it for y explicitly as a function of x. For example, if you look at this equation down here, x cubed minus sine y plus y to the 4th power equals 1, this is really difficult to solve for y explicitly in terms of x, but we may still want to find what dy dx is equal to. So how can we do it? How can we find dy dx for an implicit equation like this? Well, the answer lies in the chain rule. So we're going to consider that equation, and now we're going to try to find dy dx. So we're actually going to show how to perform implicit differentiation now. Now we need to make one assumption first. We need to assume that from this equation we really can find y as a function of x. We need to make that assumption. Now normally that's not going to be a problem. Now we're going to assume that we can find y as a function of x, at least near some point. For example, if we were to graph this equation, perhaps it would look something like this. Maybe it would look something like that. Now you see, right locally near a point like this might be the x0, y0. You see, y really can be found as a function of x because locally, very close to that point, you see the curve does satisfy the vertical line test. So this piece of the curve really does define y as a function of x. The only problem we might have would be like at a point right here where it doesn't satisfy the vertical line test. But we're not going to worry about that. We're going to always assume that we really can find y as a function of x. Now, assuming that, then by the chain rule, we have this. We want to evaluate, first of all, let's take a look at what the derivative of y to the 4th would be. Now we assume y is a function of x, so we want to evaluate d dx of y to the 4th. So we use the chain rule. We write this as d dy of y to the 4th times dy dx. This is just the chain rule right here. Notice how the dy's cancel, and you get d dx of y to the 4th. Now, before we cancel the y's, let's actually evaluate this part right here. Well, this part here is 4y cubed. Now we don't know what y is as a function of x, so we have to leave the dy dx as just y prime. And that's our answer. That's how we write it. This is the derivative of y to the 4th with respect to x. Now this causes a little bit of confusion sometimes, so think of it like this. Suppose we take the function, let's just say x plus the sine of x, and we raise it to the fourth power, and then we ask what is the derivative of this with respect to x. So we want to evaluate by the chain rule we would pick the inside to be a u, and then we would evaluate d du of u to the fourth times du dx. And notice we get 4u cubed times 1 plus cosine x, and that's equal to And so you see what we have here is we have something that looks exactly like this right here. Suppose this is our y right here, x plus the sine of y. We don't know what y is as a function of x, but just assume it's something maybe like this, x plus the sine of x. Well, notice if we look at d dx of y to the fourth, we get 4y cubed times y prime, right? This is y prime right here. So you see, that's all we're saying. We're just saying we don't know what y is as a function of x. So we have to leave this y prime right here. And that's coming from the chain rule. All right. Now as for the other terms, for example, the derivative of the sine of y with respect to x, well, we have to do the same thing. We assume y is a function of x, and then we perform the chain rule. We look at d dy of the sine of y times dy dx. Notice how these dy's cancel again, and we just recover d dx. Now, evaluating that, the derivative of sine y with respect to y, that is the cosine of y, times, and we don't know what y is as a function of x, so we just have to leave this right here. And so that is what we would write for the derivative of sine y with respect to x. So that would be the derivative of this term right here with respect to x. And then for the other term, x cubed, well, okay, derivative of x cubed with respect to x, we don't have to do the chain rule there because the variables match. We have an x here and an x here. And of course, that derivative is just 3x squared, so there's no chain rule involved there. So with all of this now, what we have here, we can now finally evaluate the derivative of y with respect to x coming from this equation. And here's how we do it. So we're going to start with the equation, and we're going to simply differentiate both sides with respect to x. Now this side, of course, is 0, so this will equal 0 here, derivative of a constant. And here we're just going to distribute the derivative to these three terms, so we get and now we're going to evaluate the derivative of each of these with respect to x. And now what we're going to do is we're going to solve for y prime. We're going to isolate the y prime on one side and put everything else to the other side. So let's take that 3x squared, we're going to move it over here, we're going to factor out a y prime from these two terms, and we're going to get the following. So notice I just factored out the y prime from here and from here. And then we have left 4y cubed minus the cosine of y. I just reversed the ordering there, so we have the minus here. And now we're just going to divide this to the other side, and we get this. And that is our answer. Now you'll notice one difference between implicit versus explicit differentiation. Notice with implicit differentiation, unfortunately we obtain y prime as a function of x and y. Notice we have x's and y's mixed in here, and there's nothing we can do about that. That's just the way implicit differentiation works. It's not as nice a form as explicit differentiation because we have x's and y's mixed together, but that's the way it works. Alright, now let's take a look at this. So here we're given the equation 4x squared minus y squared plus y to the fourth equals 1, and we want to first find dy dx. Then, for part B, we want to find the equation of the line tangent to the graph of this curve at the point 1/2, comma 1. So, first of all, to find dy dx, we have to differentiate both sides of this equation with respect to x. So we have to start with and now this side, the right-hand side, of course, is 0. And this side, we have to distribute the d dx and take the derivative of each term. So we're going to get Alright, now we have to evaluate the derivative of these three terms. This one is easy because we're just differentiating a function of x with respect to x. So this, of course, is just going to be 8x minus. Now this one here, we have to use the chain rule. We have to think of differentiating y squared with respect to y. So that's going to be 2y, and then times dy dx. Remember, the way we get this is by writing it as d dy of y squared times dy dx. That's the chain rule right there. See how the dy's cancel. This part right here is 2y, and this part right here is y prime. So that's how we got 2y, y prime. This part right here, same procedure here, except it's y to the fourth. And so this is going to be 4y cubed, and this is going to be y prime again. And so that's how we get 4y cubed y prime when we differentiate this with respect to x. Now all of this is still equal to 0, and we need to then solve for y prime. So just let's take the 8x over to the other side, factor out a y prime from what remains, and we get so there we go. Now let's just divide this to the other side, and we get and we could clean that up just a little bit by taking this negative and putting it into the denominator. And there we go. There is dy dx right there. Now for part B, we want to find the equation of the line tangent to the graph of this curve at the point 1/2, 1. Alright, well, make a little room over here. So for part B, well, to find the equation of a tangent line, we need two things, right? We need a point, and we're given that 1/2, comma 1. Now when we're given this point, just notice one thing. This point is a solution to this equation up here. If I put 1/2 in for x and 1 in for y, that is a solution to this equation. So this point sits on this curve. Notice if we put 1/2, just real quickly, if we put 1/2 in for x, we get 4 times 1/4. We get that. Putting 1 in for y, 1/2 in for x. Notice this is just how these cancel right here. We'll cancel those, and we get back 1, which is the right-hand side. So this point is a solution to this equation, so it sits on that curve. So we're given that point. What we need to find then is the slope of the tangent line. Well, to find the slope, we know what the derivative is down here, so we have to evaluate y prime of 1/2 comma 1. So that means that we have to put 1/2 in for x down here and the 1 in for the y's. So this is going to be 8 times 1/2 divided by 2 minus 4. And let's see, what does that simplify to? That comes out to be 4 over -2, and that is -2. So there is our slope, and this is our point. Now we can find the equation of our tangent line, and that's going to be y minus 1. All right, and we can clean that up a little bit. Let's write that as, see, -2x plus 1, and then plus another 1, bringing that over, plus 2. And there is the equation of our tangent line at that point. Let's see what the graph of this looks like. Just to verify everything, we'll take a look at the graph of this and the graph of our tangent line. It looks like this. So the blue curve here, that's what the graph of 4x squared minus y squared plus 4 plus y to the 4th power equals 1 looks like. Now, our tangent line then, let's see, that point right there, that's the point 1/2 comma 1. And the dotted red line there was the equation of the tangent line that we found, -2x plus 2. That's what we found. And you notice it does indeed look tangent to the graph of this equation at that point. Now you notice one thing here. This equation, if you look at the graph, it does not define y as a function of x everywhere, because you see it doesn't satisfy the vertical line test, right? But it does define y as a function of x locally, like at this point right here where we found our tangent line. Just locally, it does define y as a function of x. The only points that are problematic where it doesn't really define y as a function of x would be right here, and here, and here, where you have trouble with the vertical line test, you see. And also over here, and here, and right there. Everywhere else, locally, it does define y as a function of x. All right. Now let's take a look at this. Let's do some problems. We'll let you try some problems. So, given these three equations, let's find dy dx. So first of all, why don't you pause the video here and try to do part A. So given that equation, try to find dy dx. So, assuming that you tried it on your own, let's go over the answer for part A. So we want to differentiate both sides with respect to x. Now the right-hand side here is of course 0. And then we just have to take the derivative of x cubed, this and this with respect to x, and we get now we have to evaluate the derivative of each term here. This one's easy. This is just going to be 3x squared. Now this one we have to be a little careful. We have to use the product rule. So it's going to be minus. Now it's going to be x times the derivative of y. And we just have to leave it as y prime or dy dx because we don't know what y is as a function of x. And then plus y times the derivative of x. Now the derivative of x with respect to x, that's easy. That's just 1. So it's going to be 1 times y. Alright, so this part right here in the parentheses is this. And then finally the last term, derivative of y cubed with respect to x, as we've seen before, that's going to be 3y squared times y prime. And that's using the chain rule again. All of this is equal to 0. Now what we need to do is isolate the y prime and put everything else to the other side. So let's take the 3x squared, move that over. We have a negative y. We will move that over as well, and we'll be left with alright, so we have that. Notice we moved these terms over. We moved this term and this term over to the other side. So that's where these are coming from. Now we'll factor out a y prime here and divide what's remaining to the other side. So when we factor out a y prime, I'll write it like this. And then we just divide this to the other side and we get our answer. And there we go. There is dy dx. Notice it is a function of x and y. Let's try part B. So for part B now, we have to take the derivative of both sides with respect to x. So we'll write this as, and the square root of y we'll write as y to the 1/2. Now we want to take the derivative of this, so that's going to be, and this one of course is 0. Now the derivative of y to the 1/2 power with respect to x, we have to use the chain rule, so we have to differentiate it with respect to y first, then multiply by dy dx. So that's going to be times dy dx. Now this part right here, we're going to have to use the chain rule. We're going to have to go x squared times the derivative of y with respect to x, plus y times the derivative of x squared with respect to x. Alright, now everything's differentiated. We just have to solve for y prime. So we'll take this, the x squared y prime, over to the other side, factor out a y prime, and we'll get this. So here we wrote y to the negative 1/2 as 1 over root y. And the negative x squared is coming from this x squared right here, taken over to the other side. Now just divide this over. And there we have our answer. Now this could be simplified a little bit by multiplying top and bottom by 2 root y to get rid of this fraction. So you could multiply top and bottom by, and then this would simplify as, and there you go. There's dy dx. Let's take a look at part C now. So for the third one here, part C, we have to once again differentiate both sides with respect to x. Now the right-hand side is easy. That's just going to be 2x. This part right here is a little tricky. We have to actually think of using the chain rule with a u equaling the x times y. For example, over here, if we look at d dx of the sine of u, that's going to be d du sine of u times du dx. And this part right here is the cosine of u. So now what this is going to be, then, is we think of differentiating first with respect to the inside, which is u, and we're going to get the cosine of x times y. And then we have to multiply by d dx of the inside, which is x times y. You see the x times y is like the u over here. And then this is just 2x. Now we still have to evaluate the derivative with respect to x of x times y. So, now to do that, to evaluate the derivative of x times y with respect to x, we have to use the product rule. So it's going to be x times the derivative of y with respect to x. So that's going to be x times y prime plus, and then y times the derivative of x with respect to x. And that is just 1, the derivative of x with respect to x, and then y times that equals 2x. And now what we have to do is isolate this y prime right here. We have to isolate that by itself. So let's divide the cosine xy to the other side and then subtract this y over. And what we'll get then is alright, so we get that. So see this y right here, we moved it over, it became this y. After we divided this underneath the 2x, it's right here now. Now what we'll do is we'll divide this x to the other side, or we can also just think of multiplying both sides by 1 over x to get rid of that. And then these x's will cancel and we'll get y prime by itself. Now when we multiply 1 over x in here against this term, that x will cancel, and so we'll just have and then y times 1 over x is just going to be y over x. And there's our answer. And if you'd like to, you could put that as a common, find a common denominator to simplify that a little bit, or do cross multiplication. You could write this as so you see all we did over here was cross multiply x times 2 minus y times cosine xy divided by x times the cosine of xy. But either way is fine. Alright, now let's take a look at finding a second derivative implicitly. So in this example, we want to find the second derivative of y with respect to x given this equation. So to find the second derivative, we have to first of all find y prime first, the first derivative. So we want to find y prime first. Well, we need to differentiate each side with respect to x, so that's going to be alright, now this side of course is 0. This part right here of course is going to be 3x squared, and then we just have to differentiate this piece right here. Now the derivative of this with respect to x is going to be like that. If you're not sure of that, just remember off to the side here, we have to use the chain rule. And this part right here is going to be 2 times y minus 1. Technically times the derivative of the inside part with respect to y, which is 1. Technically you are using a little chain rule right here where u is y minus 1, right? So you differentiate with respect to the inside and you get 2 times the inside times the derivative of y minus 1 with respect to y. Derivative of y with respect to y is 1. Now that's okay. You know, dy dy, that is 1. That is okay. Times dy dx, which is y prime, and that's what we got right here. Minus, this part right here is going to be 3x squared equals 0. Okay, now we need to find y prime, so y prime is going to be there we go. Now we need to take the second derivative. So we have to differentiate this with respect to x. So then y double prime is going to be d dx of all of this. And now we need to use the quotient rule. So this is going to be bottom times derivative of the top with respect to x, so that will be, right, minus the top times the derivative of the bottom with respect to x. So that is going to be, now the derivative of y minus 1 with respect to x, that's going to be just dy dx, right? Just off to the side here, d dx of y minus 1, that is d dx of y minus d dx of 1, and this of course is 0, and we're left with just y prime. So it's going to be 2 times y prime, and then divided by the bottom squared. And now what we can do is we can actually substitute this in place of the y prime and simplify a bit. So this becomes then, let's see, we're going to get in the numerator 12x times y minus 1 minus, and then let's see, what we're going to get here is we're going to get 6x squared times this 3x squared divided by 2 times y minus 1. So we are going to get like that. So right there is the y prime. And then all of this is divided by 4 times y minus 1 squared. And that's our answer. Now we can clean this up a little bit. If you look up answers in a textbook, you'll oftentimes see it cleaned up. So let's clean this up as follows. We're going to multiply top and bottom by 2 times y minus 1. That'll get rid of this 2y minus 1 in the denominator here of this fraction. So we'll multiply top and bottom by. And then this will simplify as, let's see, 2 times y minus 1 times this term will give us, and then 2 times y minus 1, that'll cancel with this term, so that term will drop out, and then we'll just get 18 x to the 4th, and then all of that divided by 8 times y minus 1 cubed. All right. Well, that was a lot of work and just a lot of algebra, but that is how you take the second derivative using implicit differentiation. All right, and so that is all that we have to cover for implicit differentiation in this lesson.